Okay, hi, good morning everyone. Today we want to go through this worksheet on your waves. Okay, it is a practice paper, and this first video we're going to look at the MCQ questions, right? The second video we're going to look at the structured questions and see how do we do them. Okay, all right. So this first video, the MCQ one. Okay, let's briefly recap the few main ideas in waves. Okay, the first is what kind of waves are there. Okay, what kind of wave? So you have your transverse and your longitudinal wave. The second concept that you need to know are the various vocabulary from your wave. For example, what's a crest, what's a throw, what's your amplitude, what's your wavelength, what's your frequency, and last but not least, you have your two formula for wave. Okay, so the two big formula for waves are V, the speed of the wave is equals to F times lambda. Okay, frequency times wavelength. The second formula is that the frequency is equals to 1 over period. Okay, so we have these two big formulas to remember. Okay, when we do our calculation. Now, this speed, sometimes we can also use speed is equals to distance over time, also can. Alright, now here, this one we are measuring this frequency in hertz. Okay, this one the period is actually in seconds. Alright, the speed is actually in cm per second, or your what do you call this, meter per second. Okay, so now without further ado, let's go into these questions here. Alright, now a VHF radio station, okay, it's just think of it as radio station, okay, broadcast at a frequency of 60 megahertz, and they give you the amount 60 times 10 to the power 7 hertz. The speed of the radio is 3.0 times 10 to the power of 8 meter per second. Actually, it's the speed of all we call this electromagnetic waves. Alright, so light waves, radio waves, gamma rays, they travel at 3.0 times 10 to the power of 8 meter per second. Right, so this has 8 zeros. You can think of it as 3 and then 8 zeros behind. 300 million, right, meter per second. So what is the wavelength of the waves broadcast by the station? Now, so here are some notes to help you to think of it. So this question you have to apply V equals to F lambda. Okay, so wavelength. So first, using V equals to F lambda. Okay, so let me just write V equals to F lambda. Alright, we're looking for the wavelength. So first, what is V? V is speed of the wave. So speed of the wave will be 3.0 times 10 to the power of 8 meter per second. Make sure it's in standard units. Okay, this will be equals to frequency 6.0 times 10 to the power of 7 times lambda times your wavelength. Okay, so 6 times this equals to 3 point something. So what is this number actually? So actually what we need to do is to divide. So we can actually treat this like, you know, your algebra, where so I'm just going to use this pencil to show the intermediate steps. Okay, but so to untimes this, we have to like divide by this thing itself. So on the left hand side, we have to balance and do this as well. Okay, so here will cancel, right? This one will cancel. So last but not least, what is this? You can pull out your calculator, right? 3 times 10 power 8 and 6 times 10 to the power of 7. Alright, so let me just try and see. Okay, let me just show you here. Alright, okay, fraction 3 times 10 power 8 over 6 times 10 to the power of 7. So answer is 5.0. Okay, so here answer, your lambda, your wavelength is equals to 5.0 meters. So answer is A, right, over here. Okay, so far so good. So the first part is applying the formula. Second part is just applying the math algebra. Okay, number 2, the diagram shows the movement of the ball when the wave passes. Which diagram shows the movement of the ball? So you have a ball here floating in a tank of water, and then the wave passes through it. So the direction of wave is this way. How will the ball move? The ball will move this way, donkey. Right. Number 3, the diagram show a dipper. Dipper meaning like there's a liquid tank, and then there's a dipper to like dip. So it's like when you're bored, right, you take a straw and you just press the water. Same thing. So this is the dipper. Okay, so which wave property describes the number of waves passing point x per second. So one more time, number of wave per second. So what is this concept? This concept is actually your frequency, right? Number of wave per second. Wavelength is the length of one complete wave. Speed of the wave is just distance traveled by the wave over time, or f lambda. Amplitude, maximum displacement. Okay, all right. So the diagram shows waves traveling on the sea, which points are one wavelength apart. So this one very important. This one you need to know how to tell one wavelength apart. So from P to R, this is like only down to up, but it has to be like one complete wave. So it has to be like, the entire thing from one phase to the next point in phase. So if it's P don't have, S don't have, R don't have, so the only one is Q and T. So QT pi. Answer C. Okay, so it's the distance between two successive points in the wave. So meaning it can be Q to T, right? It can be Q to T over here. It also can be like this point all the way to this point like that, right? Over here to this point. It also can be P to this point, right? So what am I trying to say is it's like two successive points. So if throw, it will be until the next throw. If it's this point over here, it will be until this point over here. Okay, so that's 4. Number 5, a small surfboard moves at the speed of 5 meters per second. So this is speed. The distance between successive wave crafts is 10 meters. So this one is the speed is equals to 5 meters per second. The distance between successive wave crafts, so this one, the wavelength, is equals to 10 meters. Okay, the distance between successive wave crests, meaning we are looking for the wavelength. So what is the frequency of the wave motion? V equals to f lambda. So let us apply. Right, velocity is 5 meters per second. Frequency, I don't know. Then wavelength is 10 meters. Right, so 10 times what equals to 5. So 10 times half is equals to 5. So it will be 0.50 hertz. So answer A. Okay, can? Alright, so just a basic use of the formula. Okay, number 6, the diagram shows the variation of the displacement of a wave with the distance from the source. So what is the amplitude of the wave? The amplitude is actually the maximum displacement. And on this axis, which axis show the displacement? The vertical axis is the displacement. So what is the maximum displacement from here to here? Okay, between these 2 points like this. Right, so this is your amplitude. Okay, now another point to check is also this one, from the center, from the middle point, where is the maximum displacement? So either this or this. Right, so what is this? Answer is 2.0 cm. The unit here is cm, 2.0 cm. So answer is A. Alright, number 7, the woman tunes her radio station on broadcasting to 100 megahertz. M for mega, hertz is the unit hertz, right? So what does the 100 megahertz tell her about the radio wave? Hertz, what quantity use hertz? Actually, it is frequency. So this one is a memory thing, right? Which quantity uses hertz? Okay, so here M stands for mega, which is 10 power 6 or 1 million, and hertz is the frequency. Hertz is the unit for frequency, like cm, right? The centimeter, centi is the prefix, meter is the unit. Okay, all right, so that is for the first part. Second part, number 8. Now the diagram represents circular wave fronts coming from S, so meaning start here. Okay, and the wave fronts are about to strike a solid barrier from which they will be reflected so as to appear to come from S1. So which diagram? Okay, so here is that we have a barrier over here. So what happened to the wave? But common sense, this is reflection of the wave. So this one will reflect backwards. So and when it reflect, it should retain the same shape. So meaning answer is boy. Okay. C and D are the waves that passes through this thing, and then it will look like this, but this is not true lah. Okay, it should be reflected back. Last question 7. 4 bottles are floating in the sea. The diagram show the bottle from above. The line show the top of the wave. So when you view from the top, right, these 3 lines are what we call wave fronts. Okay, right? It's like on the beach, you see the wave forming the white line. So those white lines are called wave fronts, and those white lines are actually like the places where the wave particles are in phase. Okay, so a wavefront is an imaginary line joining points of the wave that have the same phase, right? So here, which two bottles are on the same wavefront? Okay, so meaning one, and then this wavefront is here, correct? But there's no other particle along one. Two, the wavefront is this imaginary line. From the top of the wave is this line, so there's no other line. 3 and 4 though, although even though they are not on the crest, right? Even though they're not on the crest, but they are at the imaginary line, and then they are at the same phase, meaning they are on the same part of the wave, right? So 3 and 4, they are on the same wave front, or they are on the same phase. So answer is donkey, right? On the same phase like this. Okay, that's all for the MCQ. So the next video we're going to look through the structured questions. Okay, thank you. Bye bye.